My name is Daniel Crenshaw, and this is my Lab 4 report. For this lab, we were tasked with using a magnetometer to analyze how the magnetic field of a dipole works. The main physics principles used was the Biot-Savart law and the definition of a formula of a magnetic field. Here is a preview of the results of the lab. Here we can see how the different distances of the bar magnet related to the magnetometer affect the magnitude of the magnetic field for the X component. The system for this experiment was the phone's magnetometer chip and the bar magnet. The surroundings were everything else, including the Earth's magnetic field. The materials used for this lab were a phone, along with a magnetometer app, a bar magnet, 2 yardsticks, tape, and an Excel sheet to record data. To conduct this experiment, we first needed to locate the magnetometer chip on the phone. To do this, we moved the phone along a yardstick while the bar magnet stayed at one end of the yardstick. We then determined when the X value of the magnetic field was at its highest point, and then repeated this process with the phone turned 90 degrees. Finally, we used tape to mark where the chip was located. We then moved the phone along the yardstick to determine what distance from the bar magnet was needed to acquire a certain X value. On axis, we measured the distance from the phone to the magnet while the X component was at 20, 70, 120, 170, and 220. Off axis, we measured the distance from the phone to the magnet when the net electric field was 100. By taking another look at the results, we can see that the closer the phone and the bar magnet are, the higher the X value of the magnetic field is. We can use the data from the graph to calculate the magnetic dipole moment of the bar magnet, which was 0.68 meters squared. We then use this value to help create the model for the experiment. Here we can see that we used our 0.68 value for mu mag. We then used function dipole B, and with a scale of 3000 for the arrows and distance of 0.15, we can see in the model on the right side what the vectors look like of the electric fields. Some possible errors that may have occurred during the lab are improper processes during the creation of the coding model and using incorrect measurements due to the presence of other electronic devices. Now, what if we hadn't oriented our experiment to compensate for magnetic north and had instead laid out our meter stick at some intermediate angle with respect to the Earth's magnetic field and how the results have changed? If we hadn't oriented our experiment properly, the Earth's magnetic field would be included in our measurements, which is something that we wouldn't want. This is because the data would differ by a factor of cosine theta based on the Earth's magnetic field. And overall, this would mean that our B values would be smaller than what we recorded or what we thought they would be. And finally, what if we were to stick 2 identical magnets together end to end and run the experiment again? How would we expect our measurements to differ? If we were to stick 2 identical magnets together end to end, our results would effectively double for each distance that we recorded. The slope that we saw in the graph earlier would stay the same, but the intercept would be double as well. And that is it. Thank you for watching.